Okay, so today we're going to calculate average rate of change for a function over a given interval. So over this specific interval. So if our function is a linear function, if it's linear, does it matter the interval they give us? What do you think?
No.
No. Why? He's right.
Constant.
Because it's always the same. Y'all are all right. It's constant. It's always the same. Now the first one they give us is not linear. It's what kind of function? Quadratic function. So the interval that they give us, we're finding the average rate of change just over that interval. Because if we picked a different interval, we have a different average rate of change. Yes. Okay. So on this first one, they're asking us to do the average rate of change over this interval. So this first x is our first x value. The second x is our second x value. Now, when we do average rate of change, and last year I called this AROC. Did they call it that in the middle school? Average rate of change, AROC. Okay, average rate of change is just the change in your y's over the change in your x's. And the Greek symbol delta means change.
I see a triangle.
So the change in your y's over the change in your x's. So we've got our x's right here. That was defined in our interval. How do we find our y's?
Plug it in.
Plug it in. Very good. So if we plug in 0, obviously all that goes away. And we're left with just -2. There's our first ordered pair. Now we plug in 3. 3 squared is 9. 9 times -2 is -18. Take away 2 more is -20. So if we're finding the average rate of change over this interval from 0 to 3, we would do -20 minus -2 over 3 minus 0. What happens to minus a negative?
Adds.
Very good. So I'm getting -18 over 3, which gives me an average rate of change over this interval of -6.
Oh, x squared minus x1.
The change in your y's is y2 minus y1 over the change in your x's is x2 minus x1.
We sung a song about this.
Oh yeah, we had to write songs about it to remember it in 7th grade.
Awesome.
Let's hear them.
No, let's not do it.
I don't remember it.
Okay, you try. Number 2.
You try. I don't know if I can do this. I think I'm just going to
Pretty sure that's not right.
14.
It's 14, like a positive.
It's a positive.
Oh, wait.
-14 minus.
No, I just think it's
So when we do the average rate of change, we're going to do -34 minus -20 over 4 minus 3. So this minus a negative makes a positive, so we get -14 over 1, which gives me an average rate of change of -14. Questions? No questions. Okay. All right, the next one is comparing the parent graph for a quadratic function, y equals x squared, with our linear function here, y equals x. If it's linear, isn't the average rate of change the same as the slope?
Yes.
Yes. What is the slope of this?
1.
1. So the average rate of change
1.
is actually constant. It's just 1. Now if I plugged in 0 and I plugged in 3, I'm going to get 0, 0, and 3, 3. And when I do 3 minus 0 over 3 minus 0, I get 3 divided by 3, which is 1. So if you're chugging along on your quiz and you accidentally do it, you should get the same thing as the slope. All right, now let's take a look at that first one. So if we plug in 0, 0 squared is 0. But if we plug in 3, 3 squared is 9. So the average rate of change for that first quadratic function for y equals x squared is
3.
9 minus 0 over 3 minus 0. So 9 divided by 3 is 3. So the average rate of change for this particular quadratic is 3 times larger than the linear function. It's increasing faster. But this 3 times is because it's over this specific interval, over the given interval. If we change the interval, would it stay 3?
No.
No. This would also change.
Is that a coincidence that it's 3 numbers in between there, and then 3 is the times that it's larger? Or is that always going to be the same?
Okay, I hear what you're saying. If we were to do 4, we'd get 16 divided by 4, which is 4. If we were to do 0 to 5, we'd get 25 over. But if we were to do 1 to 25, that would be different. So, yes and no. It's because it was 0 to 3. All right, let's look at another word problem, similar to the one some of you had the opportunity to start when we did the warm-up a few moments ago. All right, this one. A small computer company keeps track of its monthly production and profits over 3 months. The quadratic function. So this is how they've modeled what's going on in their company. This function describes the data where N represents the number of computers produced and P is the profit. Find the interval over which the number of computers is increasing and what is the average rate of change. Well, wouldn't it be increasing all the way up to the max?
Yes.
The vertex? Okay, now on this particular one, I know my y-intercept is negative 400, which means when I produce 0 computers, I'm losing money. Because I had to buy materials, I had to pay for electricity to the building, all those things are going to cost me. So even if I don't produce anything, if I produce nothing, I'm losing money. But after that, we start gaining, right? And we're going to gain up until this point. It's increasing up till here. So how do I figure out where that point is?
Convert it to
Vertex
vertex.
one, vertex, vertex one.
Okay, so how do we do that?
Negative b over 2.
Negative b over 2a. So we're going to do negative 160 over 2 times negative 1.
80.
So we get positive 80. So what does that tell us? That tells us that we should sell 80 computers. And if we sell 80 computers, how much do we make?
We gotta plug it in.
Plug it in. So we're going to do P of 80 now. And so we get the opposite of 80 squared plus 160 times 80 minus 400. And this gives us 6,000. So we know that this point right here is 86,000. So now how do we find the average rate of change over
Plug
this
0 for
increasing
y.
interval, which is the second question?
Plug 0 in for y.
So we have the increasing interval, from 0 to 80. And now what is the average rate of change over that interval? So we're going to do the change in our y's, which is 6,000, minus the negative 400, over the change in our x's, 80 minus 0. So we get an AROC, an average rate of change, over this interval from 0 to 80 up, now I'm going to switch colors to blue so it stands out, 80. But this is a word problem, and with a word problem we ought to be able to give a unit. 80 what?
Computers.
Okay, so what does these top numbers represent? Money. That's our profit
Per computer?
per computer. Our profit per computer.
So how would it go back down? Just asking like that.
How does it go back down?
Yeah.
What happens is you produce more than you can sell, and you have to pay for materials, you have to pay labor, and so you've got inventory just sitting on the shelf.
So where's 2 points?
Oh, yeah.
Okay, so the back is your homework. Answer key is already posted online. So do the homework and check it.